Hey folks, Mr. Dell here. We're looking at a problem where we've got a couple systems of equations and we need to determine if there's a solution and explain what we see with this. So this is a problem that is from CPM's course 3, and this is section 7.1.1, specifically number 7-10. So here's what it says. It says find the solution for each system of equations below if a solution exists. If there's not a single solution, explain why not. Be sure to check your solution if possible. So here's what we've got. We've got on A, I've got two equations. Now, normally when we're solving a system at this point in the learning process, at this point in the curriculum and such, you've only learned about the equal values method, right? Equal values method. As well as graphing. You could graph and see what the solution is by where, so it's either by equal values method or by graphing and then finding where they cross. So where they cross is the solution, or use the equal value method. That's the only two things we have normal. But if I look at this, the equal values method usually is set up to where you have it as y equals, right? You've got to have your equation in y equals form. So y equals something and y equals something, and then you set those two things equal to each other and solve for x, right? So that's the process of the equal values method. But if I look at this, I have these equations where right now they're not set up to where it's y equals. So I could go through the process and get y equals, but I'm going to stop because what I notice right here, which looks interesting, is I have this x plus 4 equals 2. And then the other equation is x plus 4y equals 10. So remember, we're looking for a solution. A solution is an x comma y, the same x comma y, right, that would work for both equations. So I'm looking for a set of numbers that I put in here that would work, that would make both equations true. If I think about it, x plus 4y equals 2. And if I do the same numbers, x plus 4y, could it equal 10? No, there's no way that there's not an xy that is common, right? There's not an xy that is actually going to work, because you can't pick the same set of numbers to get 2 and then the same set of numbers to get 10 and doing the exact same operation. So there's not a common point. So that being said, what we have is no solution for this question. And what would this look like graphically? If I were to graph this, what you have is parallel lines. That's why. So the deal is, if I were to graph those two equations, they would be parallel lines. So we have no solution because parallel lines. That's what's going on here. So if it says why not, that's why. These are parallel lines because they have exactly the same slope, but different y-intercepts. Okay? All right, that's A. B, when I look at B, now again, I've got two equations, and for me to put them in the y equals format would be no fun. So I can think maybe there's something fishy here. And if I think about this and I look, 2x plus 4y equals negative 10, and then x plus 2y equals negative 5. What do you notice about these two equations? If I were to take this equation here and multiply every single thing by 2, what do I get? If I multiply the 2 times x, it becomes 2x. 2 times 2y, it becomes 4y. 2 times negative 5 becomes negative 10. Now look what we've got. This equation and this equation are identical equations. It's just one had a factor of 2 and one did not. It doesn't change the line. It doesn't change the solutions. They're going to still be the same solutions. So what we have is, it's the same line. And if it's the same line and I were to graph them, they would what? When I graph them, one line would be right on top of the other line. So how often are these two lines crossing? Infinitely, right? They're crossing infinitely. They're always crossing. So therefore, we would say that there are same line, therefore infinite or many solutions, you could say. Infinite solutions or many solutions. Infinite solutions, or we could say many solutions, if that makes more sense. So that's the answer for this question, because we have the exact same line, so it's always crossing each other. So therefore, there's an infinite amount of solutions. There's a whole bunch of points that would make this work for both of them. All right, there we go.